Alright, so in our last video, we talked about taking a sample and summarizing it. So in that example, we've created a p-hat, or our sample proportions. Earlier in this module, though, we talked about is that if I took a sample and you took a sample, we could get different sample proportions and more than likely would get different sample proportions. So we want to know, how do I know when I can trust a certain sample proportion? So to understand this idea, we're going to simulate first what's called a sampling distribution before we talk about it in a more mathematical terms and how we're going to actually use that. So for our example, we're going to be using StatCrunch. You can of course just first watch me when you are doing this, or you can actually try to do it along with me. That is totally up to you. But let me give you the idea of a setup of the idea of what a sampling distribution is doing. So let's pretend that in front of us right now there is a bucket that has a whole bunch of beads in it. And these beads are two different colors. They are yellow and they are black. And we are interested in figuring out, well, what percent of all the beads in there are black? That's my goal. That's what I want to find out. And I'm not going to count out every single bead. So what I would probably do is take a sample from it to try to estimate what that percentage of black beads actually is. So that's going to be our goal. Now there's going to be a little piece of information that we need for this applet, but in reality we would not know it. And that is that we're going to use this P of 0.4. Remember, P represents our population proportion. Or what I'm saying is here is the person that put this bucket of beads together put 40% black beads and 60% yellow. But remember, they didn't really actually tell me this information, but that's actually what I'm sampling from, is this population that is 40% black and 60% yellow. So what we're going to do is just take a sample of 10 beads first while we do this. So if you want to follow along, or even if you want to do this later, we're just going to bring up our main StatCrunch area, and I'm just going to click Open StatCrunch. I don't need any data set or anything for this. And then it's going to go to Applets, Sampling Distributions. And these directions are also in the notes. I'm going to click the binary option, change this to be 0.4, meaning that I have 40% black beads. And just so that you can get the same information as me, I'm going to use this fixed seed down here and just put 1, 2, 3 as my seed. This will allow for you to get the exact same results when you go through and do this, instead of getting different results than me. Alright, so what pulls up here is just the idea of what my population looks like. 60% or 0.6 are yellow beads, 40% or 0.4 are black beads. And so I'm first just going to take a sample of 10 beads. And at the top here, I'm going to click just one time. So it's going to take my sample of beads. From our sample, we got 3 yellow and 7 black beads. So my sample proportion then of black was 70% as black beads. And then it took that 70% and put it on my picture down here. This is going to be a sample proportion, this 0.7, so let's label that here first together. So our p-hat that we just got was 70% or 0.7. Now as it says, I'm going to hit the reset above, and now I'm going to click 5 times instead. So up here is reset, and I'm going to click 5 times. Now what this is going to do is the exact same thing it just did, but 5 separate times. The good news is we also get to see it in action. So it's going to take a sample of 10 beads here, figure out what percent is black, and put that number down here. Take another sample of 10 beads, what percent was black, put that number down here, and I'll do that a total of 5 times for us. Now each of those numbers that it just put on here were sample proportions. But now I've got some extra information down here. It recorded a mean, a median, and a standard deviation. So the first thing I'm going to do is just record those numbers for myself. So my mean was 0.34. That means if I found the mean of all my numbers down here, these 0.3s and then this 0.5, their average or their mean is going to be 0.34. Our median value was 0.3. And our standard deviation was 0.0894. So again, I just recorded those numbers here like it told me to. Okay. Now that I was just doing it 5 times, I'm going to really blow this up, so I'm going to first reset it. And I'm going to hit 1,000 times. Now once I hit the 1,000 times, it's not actually going to show me each individual time of it selecting the sample and putting the number down here. But you have to visualize it doing that. That's what it's doing. I'm going to take a sample of 10 beads, get what proportion were black, put that number down here, and then do that 1,000 times. All right, so if I click my button, here is what we get. So the information I'm most interested in now is what's going on down here. Notice again that I got a mean, a median, and a standard deviation, and I'm going to record those numbers. So our mean was 0.394. Our median was 0.4, and our standard deviation was 0.1579. So again, just recording those numbers here. Now what you'll notice my mean and median here, now that I've done this 1,000 times, is really close, or the median is exact, what my population value is. Right, so there was 40% black beads in my big bin. On average, when I pulled these 10 beads out each time, I got about 39.4% of the time I got black beads. My median was 40% black beads. So that's some good news, right? Those numbers are pretty close to what I'm getting. Remember, those standard deviation is more of a measure of spread, how different things are. So we're going to see, well, what does that number really mean? Remember, it gives me an idea of kind of how spread out my numbers are along here at the bottom. Okay, we're going to do the same thing now with a sample of 20 beads. So I'm just going to go over here and change this 10 to 20. Everything else will automatically reset for me. Now I'm going to go ahead and jump straight to doing this 1,000 times. The only thing that it's doing is different is it's sampling 20 beads each time instead of 10. If you need to hit it one time for yourself to understand it, feel free, but just sampling more beads each time. So this time, here's what my 1,000 beads look like. And I also got my mean, my median, and my standard deviation. So this time my mean was 0.4003. My median was still 0.4. And my standard deviation is smaller. It's 0.1102. We'll actually see as our graph is less spread out. That's why our standard deviation is smaller. So what do you think would happen if I change this 20 to 50? Do you think that's going to affect the mean or the median or the standard deviation? And if so, how do you think it would affect it? Take a moment and think about that here. Come up with some guesses based upon what you saw with the 10 beads and the 20 beads to see if what you think is going to happen does happen. So pause it here if you need to, because then we're going to do it. All right, so now that you have your guesses down, we're just going to change this to 50. Again, same population, so 40% of all the beads are black, 60% are yellow. I'm going to go ahead and do this 1,000 times. And I'll go ahead and record my mean, my median, and my standard deviation. All right, so our mean this time is 0.3999. Our median is 0.4. And our standard deviation is 0.0687. So if I compare that to what I had before, well, the median is exactly the same, so that didn't change. The mean is about the same. It's slightly different, but it's about the same. But my standard deviation did get smaller. So that's what I'm going to say did happen. So my mean and my median didn't really change. My standard deviation got smaller. And what I'll also see, here just one sec, is if I look at my graph, right, it began to look, and that's kind of like that normal distribution that we learned in Module 1. So hopefully, what are we going to take away from this applet? All right, so first of all, you could do this another time. If you use the same seed number we used, you'll get the same numbers. But if you use a different seed number, you're going to get at least slightly different numbers from us. So extending this idea. All right, so remember our symbols first. P represents the population proportion. P hat represented the sample proportion. Right, and as we saw in our activity here with this applet, that sample proportions can be different based upon who our sample is made up of. Right, so whatever beads I sampled affects the sample proportion. But we can actually predict how much we can expect our sample proportions to vary, or that is how much we can expect them to be different. So what should we have noticed from our activity, this applet here? So as we took a larger sample, and by that I mean we started by taking samples of 10 beads, then we took samples of 20 beads, then we took samples of 50 beads, right? So we changed the sample and got it larger each time. We should have seen that the mean and median didn't really change. Our standard deviation got smaller. And finally, the graph begins to look like our normal distribution. Right, it begins to have that bell-shaped looking curve to it. Right, so if we look at this graph, right, it looks pretty bell-shaped like we saw in our very first set of notes. So we're going to use this idea as we talk more mathematically and like actually the formula behind it of what a sampling distribution does and allows us to figure out what types of numbers to expect. So for example, if I was looking at this, if I sample 50 beads, would it be very likely for me to get a sample proportion of 80% black beads? Well, 80% is here, right? That never happened in the 1,000 times that I did it here. So that would be very, very unlikely to happen. Versus would I expect to get a sample proportion of 50%? Well, that's about here. That happened quite often. That seems like a pretty reasonable number that could happen. Right, so I can use this sampling distribution to figure out what types of values I can expect to see and know when something is unusual versus when it's pretty usual for me. So that's what we're going to worry more about formally defining in our next video.